Welcome students, हम डिस्कस कर रहे हैं the second numerical from the exercise for the chapter mechanical properties of solids. So let's start. The question says we have a block of mass 37 kilograms which rests on a rough horizontal plane having a coefficient of static friction as 0.3. Then find out the least force required to just move the block horizontally. So this is how the story is. हमारे पास एक rough horizontal surface है, and so since we have a rough horizontal surface, I write rough over here. And इस horizontal surface पे we have a block resting on it, and this block का mass is given to us, and हम यहाँ पर represent करेंगे as capital M. Now, if we apply some force on this block won't move. Why? Because since the surface is rough, this movement will be countered by the frictional force applied by the surface, which is proportional to the coefficient of static friction given to us in the question. So the only condition where this block moves in the direction of the force is when our applied force, so let me mark it as FA, value is greater than or equal to the maximum static friction, or FL, that is the limiting force of static friction. So if we need to calculate the least amount of force required to move the block, that is applied force, we need to first calculate the limiting force of static friction, because our FA is equal or greater than limiting friction itself. So now let's try to reapproach our question. So given है हमारे पास the mass of the block which is 37 kilograms. Second quantity जो दिया है, that is the coefficient of static friction μs, that is 0.3. And then third quantity हम हमसे ही लिखेंगे, that is the value of acceleration due to gravity, which is 9.8 meter second square. Okay, because we'll be using this value. And हमसे पूछा है to calculate the applied force on the block. Now the formula to calculate this applied force, as I said, applied force is greater than or equal to our limiting friction का force, whose formula हमें पता है is given to us as coefficient of static friction into the normal reaction. And since the block is resting on a horizontal surface, in this case the normal reaction is simply mass of the block times the acceleration due to gravity. So from this I can say that from our formula 1 we get the minimum or the least force which we need to calculate. So least required force is greater than or equal to mu s times m into g. And if we were to substitute these values, mu s ka value is 0.3 into mass is 37 into g value is 9.8. Now you can use the logs to calculate the further equation, but for the simplicity video may we'll skip that portion, and if you were to multiply these terms, you will get your force, that is the least force, as 108.8 Newton. So this is the least force required, that is 108.8 Newton. Now, if you want the PDF of the given solution, make sure you check the link given in the description. Have a nice day.